I'll repeat the question.
What we're gonna do, the first thing we're gonna do. All right, let me remind you. We're gonna convert the feet and inches into just feet. And to do that, we will take the inches and make them a fraction of a foot by placing the
10
inches
over
over
12.
12. So we'll get 45, writing this in our mixed fraction, 45 and 9 over 12. And all of this is feet. All right?
Yeah.
That is also equal to, if we reduce it, 45, and we change 9 over 12 to
That'll be 3 over 4,
the 3,
right?
3 over 4. Yes, 3 over 4 feet. Okay? Then we are also going to do that with the width, where we have 28 feet, 6 inches is equivalent to 28 feet. Well, let's leave the feet out. 28 and 6 over 12,
Yeah.
which is also equivalent to 28
Yeah.
and a half feet. All right? The next step that we'll do is we will convert the mixed fractions to improper fractions. And to do that, we say the denominator, which is 4, we are going to multiply the whole number by the denominator, and we will add.
That's like 180, 183.
We'll add the numerator, which is 3, and our answer is, you say 183.
Yeah. Yeah.
So we'll get that to 183, and we're going to put that over 4. All right? So our 28 and a half is the same as 28 times 2 plus
You put 3. Hold on. Yeah, you put 3.
3. Oh God, I don't know. Plus 1 equal
Yeah, like 57.
57
Yeah.
over 2. Okay. Then we reach step 3, which means now we are multiplying 183 over 4 times 57 over 2. We multiply the top, multiply the bottom. What we get on top? 183 times 57. Zoe, you with me? Because I know Tamia with me. Zoe, you with me?
Yeah, I do.
Okay.
All right, yo.
Okay. You'll be easily distracted now. What we get on top?
What the answer?
The top, just the top.
10,400.
10,431. 431. And we're dividing that by 2 times 4, which is 8, right? Right. And so our answer here is
1,303.875.
Oh, hold on.
Huh?
All right. What do you say again?
I say 1,000.
303. 300 and
3.
uh-huh.
0.875.
1,300 303 303 point what?
87. Hold on. Yeah, 8.875.
Okay. And what we'll have to do with this is we'll have to round this off to the nearest square foot, which will give us what? 1,304. And we'll put square
Square feet.
feet. Okay? Now, that right there will give you an additional few points to calculate the floor area. To calculate now floor power is simple, which means floor area times 3VA, which is our constant value, and that would be 1304 times 3, which will give us, what does that give us?
Hold on.
3, 9, 12. 3, 9, 12. Okay? 3,912. And that would be VA. We could leave it at VA. Or in this case, we could put watt. W, which is the unit for power. So electrical power, as you know, can be represented in watts or kilowatts or VA, which means voltage ampere. All right, and we know voltage ampere. We know voltage ampere is as a result of volts times current, which gives us power. If we go back to our triangle, our power triangle, go back to our power triangle. We'll have power, which is P on top. We'll have I, one side of the bottom, and E on the next side, which is our pi. Power, I for current, E for voltage. So power is equal to I times E. That's where we get voltage amperes from. All right, so that should be clear. Okay, that should be clear. Any questions before we move on to the next question? All right, good. Y'all want screenshot? No, y'all don't need to. Y'all want to watch the video. Okay, let me move on. I gotta clear that. All right, let's go down. All right. So the questions we just answered a while ago was the floor area and the floor power. Now, let's look now. Here we have a transformer calculation, and we're going to work this together. All right, now your transformer calculations are based on the formula. Anybody remember the formula?
What are they?
I
Transformer calculation. What are some key things we must remember about the transformer?
the numbers of turn.
Okay, so numbers of turns. Where am I in hashtag? Number of
The
turns.
turn ratio.
Right. Number of turns. And that is now N what? NP, right? Over N S.
S.
P means what?
Primary.
Primary, good. So when you look at this here and you see PA, that's primary turn or the primary side of the transformer, and the SEC is secondary. Okay, number of turns, turns ratio. What else we remember about this transformer?
I
What else we remember about this transformer? What else we got to keep in mind? All right, so we have the turns ratio, we have the number of turns, we have the current, and the current is given as I, and it is IF over IP, current secondary over current primary, and there's one last one. What is that? Voltage.
did you say? Oh yeah.
Right? And it is, you can use V or E. Voltage is E or V. Okay, so if you see a V in the thing, it's the same as the E. So let's use EP over EF. All right, so remembering that, we can work out any thing that refers to transformer. Another important thing to remember is that power input is equal to power output, which means a transformer is the most efficient machine known to man so far. In fact, it is 100% efficient, meaning whatever power you place into the transformer will be the same power you get out of the transformer. Now, usually when you're doing a transformer calculation, the first thing that you must pay attention to or do is you must calculate the turns ratio. You calculate the turns ratio first. Okay? Now the turns ratio is based on you having the value for any two of these. If you have the number of turns on primary or secondary, or the number of, or the amount of current on the secondary and the primary, or the amount of voltage on the primary or secondary, or if you have playing music, and do it cut the music, mute your mic. All right, or
Time minutes, Manyo.
man, listen to me, man.
Hold on.
Put the mic on mute, man. All right, now the power input equal the power. If you have the power and the current or the voltage, you can